Welcome, everyone. My name is Barbara Bechter. I'm co-director of the Wilson Research Institute for Health and Wellbeing, and I would like to welcome you all to our third public lecture. Today, our speaker is Professor Amanda Ellison, who is going to talk about headaches and what they say about you. Amanda began in science by doing a natural science degree in Trinity College in Dublin, specializing in physiology. She then did the PhD in neuroscience and started her research career in Oxford University, where she was part of the team that pioneered the use of transcranial magnetic stimulation in human neuroscience. She then moved to Durham University and is still interested in how different parts of the brain communicate to bring about everyday function, and is now a professor in the psychology department here at Durham. Amanda is also a committed interdisciplinarian, holding the view that we can't truly understand a problem until we look at it from all angles to find a solution. It therefore is just natural that she has been for the past 4 years the executive director of the Wilson Research Institute for Health and Wellbeing here at Durham. Amanda has written 2 books, the latter of which is the subject of this talk today. So Amanda will take questions at the very end of the presentation. If you do have any questions, if you do want to write comments, please use the chat functions. Over to you, Amanda.
Hello, everybody. Thanks for coming to this lecture today. I'd like to talk to you about headaches, the main different types and what they feel like and why we get them. So during lockdown in June 2020, Bloomsbury published my book, which was called Splitting, the Inside Story on Headaches. Well, of course, lockdown isn't the time to bring out a book aimed at helping lots of people, but there we are. Lockdown was an interesting time for headaches, with many people experiencing more due to the pressures of homeschool and working from home simultaneously, but also changes in exercise, eating, and particularly drinking habits. However, many people experienced less headaches as they had more time for self-care and were relieved of daily commutes and what have you. So you can see, if ever we needed any more proof, that our lives and experience have a huge effect on how we feel and the incidence of headache. But how? What's the physiological link? This is what I want to talk about today, to link what is happening in our brain to our behavior through our bodies within the environment in which we find ourselves. So reasons why I wrote the book are many, but one in particular relates to my annoyance, because it always comes back to what annoys us. When headaches get lumped into, all headaches get lumped into the migraine category. And that's simply just not true. And a poor diagnosis of the type of headache being experienced can lead to incorrect assumptions about their cause, and also incredibly poor treatment advice. Headache does not appear on the curriculum of 75% of English medical schools. And the WHO warns that headache is underdiagnosed, underrecognized, and undertreated. And so that's another reason why I wanted to write this book. It was to empower people to understand their own experience and act accordingly. Also, as a physiologist and neuroscientist, it gave me great pleasure to pull together all of the different research strings, from biomolecular to vascular to neuronal to experiential, to see where the state of play is now, where our truths lie, and where the odd urban myth or 52 could be debunked. And so these are the stories that I'd like to tell you about over the next 40 minutes or so. Okay, so one headache that we have generally all felt is the sphenopalatine ganglioneuralgia, otherwise known as brain freeze. But this headache is a really great way of explaining how we feel pain in our head. The thing about brain freeze is that it doesn't come from sensitivity in our teeth as commonly thought, but it's caused by extreme temperature change in your mouth, or your buccal cavity, as I like to call it when I'm shouting people out, tell them to shut their buccal cavity. It works for me. This sends off signals from the palate or the roof of the mouth particularly, and that happens when you eat or drink something cold. It even happens to surfers, most predominantly off the northeastern coast of England. Gobbling your ice cream leads to a higher instance of brain freeze headache, as Maya Kazarowski, the youngest author in the British Medical Journal, found. She was 12 at the time. But we don't feel the pain in our mouths particularly. It presents as a stabbing pain at the temple, so just about there, which seems really weird. But this is an example of referred pain, in much the same way as pain in your heart is felt in your arm. Pain signals in your head are picked up by the trigeminal nerve, which looks like this. And it's so called because there are 3 branches. And the pain is picked up anywhere where these 3 branches are on your face and head. And it's carried up to where the 3 branches meet and off up to your brain. So if we're talking about your mouth, it's this red part here. So your brain has to then detect what that pain feels like and where it comes from. But your brain mistakes where the pain is coming from because it's lumping all that input from the whole face together. And so you feel it in your temple as a dull throb. But there's another reason why you feel it there. It's because the brain detects a change in temperature and wants to keep the brain nice and warm for optimal working. Remember, you're not dead until you're warm, sober, and dead, because your brain actually will shut down, both in cases of extreme alcohol poisoning, but also in cases of extreme cold. So many a body has woken up in the morgue for people particularly who are sleeping rough. So I digress. You get a rush of blood to the head, a widening of blood vessels to bring more nice warm blood to that area to counteract the temperature change. And that causes the throbbing. It usually goes off within 10 to 20 seconds. Some people experience an exquisite rush afterwards, and that's because of the natural painkillers that are released by your brain. They're called endorphins. They're part of the rush, that feeling of reward, and that guides many of our behaviors like eating and drinking, and indeed sexual activity too. Now, the widening of blood vessels is a common theme underlying all headaches, but the phenomenological effects can be different depending on their cause. For example, vasodilation seen in sinus headache leads to the feeling of being hit with a spade across the face. Many of you will have experienced this. And if you have experienced this and you have not actually been hit across the face with the spade, then the chances are you are experiencing a sinus episode. Your sinuses are air-filled cavities behind your face, and you have 4 of them. They're lined with mucus-secreting cells that usually drains away. But if you inhale an irritant or an allergen or a bug, your immune system kicks into gear to isolate it and eject it. And part of this response is an increase in the amount of mucus that's produced to trap the bugs, which is why we feel bunged up or have a runny nose. A big histamine response, which brings more blood to the area so that white blood cells can be released to kill the bug, which explains the heat and the flushing and the throbbing. And just like brain freeze, the pain signals may originate in the nasal area, but may be felt in the forehead as it's all picked up by the trigeminal nerve. In fact, where the pain is felt can tell us which of your sinuses are under attack. A problem in the frontal sinuses leads to pain in the forehead, whereas pain in the cheeks just below the eyes, with perhaps toothache and generalized headache, that indicates a maxillary sinus issue. Pain between your eyes, most common, comes from the blockage of the ethmoid sinuses, whereas a really diffuse headache comes from the inflammation of the sphenoid sinuses, which can also lead to double vision. Now, happily, decongestants are a good treatment for sinus congestion, with menthol being a very popular treatment when our nose is blocked. They look like chapsticks, and you stick them up your nose and breathe in. But if you stick your chapstick up your nose and breathe in, nothing happens. It has to be some kind of Sinex stick with menthol involved as well. Now, it doesn't actually directly unbung us, although that's the experience that we have. What menthol does is it fools our sensory receptors into thinking that the area is cooler. It has no effect on airflow whatsoever, but we subjectively feel clearer, and that decreases the inflammatory response from our brain, leading to a constriction of those widened blood vessels, giving us a little bit more room in our ducts. So menthol, in effect, sells our brain a dummy. But even though you now know this, it still works. I promise it will still work next time you stick your menthol stick up your nose, but not your chapstick. I promise you that as well. Now, if you are interested in finding out if your headache is sinus related, then you can complete the SNOT 22, which is a questionnaire developed by Jane Piccirillo out of Missouri, which is an excellent example of when an acronym works on so many levels. It stands for the Sino-Nasal Outcome Test, and there are 22 questions ranging from how you feel to its impact on your life. So if you're interested in taking that, I've put the link in the slides that will be as part of a PDF in the support documents for this particular lecture on the Wolfson website. Now, not being able to breathe properly is very stressful, but of course there are stressful things aplenty in our lives. And one distinction that I would like to make here, though, is between emotional stress and physical stress. Emotional stress, as we all gather, comes from deadlines, comes from work, it comes from children, it comes from life worries. Physical stress comes from your posture, injury, inflammation of a broken body. The issue is that your brain doesn't make the distinction between those two. They will both result in tension-type headaches, particularly if the musculature of the head and neck are compromised. And that often happens when you're trying to work on a laptop on a sofa, as many of us did over the past 18 months. A tense body makes us emotionally stressed, and an emotional stress makes our body tense and stiff. We hold ourselves differently, so we can't make the distinction between those two things. And another issue that complicates the tension headache is our behavior around stress. So if our brain detects stress, it concocts strategies to relieve it, and it pulls on your behavioral strings. So if you've had a really stressful week, you might think the best thing to do is to unwind and have a glass of wine or 10 and a takeaway and pass out in front of Countdown on Friday afternoon. And you wake up with a banging headache. Well, alcohol has a double whammy effect. Ethanol causes vasodilation in the blood vessels of the face. That's that flush that many of us get when we drink alcohol. This fools our brain into thinking that we're under attack. And lots of histamine and inflammatory agents are released, and that increases mucus production, and that makes us feel snotty and bunged up. And the more alcohol you drink, the more dehydrated you get. A big salty takeaway won't help with that either. That makes your mucus thicker as well. So you tend to have quite a big sinus episode after a big night with lots and lots of alcohol. But the dehydration is pretty systemic. Your kidneys need to pull water from the blood and the tissues of the body to dilute the ethanol so that we can safely excrete it. Well, the brain's over 70% water, so it's a veritable oasis that the kidneys can tap into in times of need. The brain can literally shrink, pulling on the meninges or the membrane covering the brain, activating the pain receptors there. Now, the brain itself doesn't have any pain receptors. Where the pain comes from is from the trigeminal receptors that are embedded in the membranes and the blood vessels. But why does vasodilation cause pain? Why does that widening of blood vessels that we get, why does that cause pain? Well, headache is in fact our early warning system that vessels are widening beyond their comfortable limits. And that's really important because if blood vessels burst, that can be catastrophic for brain tissue because blood kills nerve cells on contact. And your brain is the most vital organ in your body. So you need this very early warning system. Now, you might recognize blood vessels bursting in your brain as hemorrhage, otherwise known as stroke. Stroke as a term isn't very descriptive. I'm not in love with the term at all. It used to be called apoplexy, which is better. But then people realized that it changed lives so quickly and irrevocably that it was like the stroke of the hand of God. And so the term stroke stuck. So we really need to listen to our headaches, as they're telling us that not all is well. Stress induces an adrenaline response that brings more blood and its nutrients to our vital organs like our heart, our lungs, our brain, and away from our periphery, which is why when we're under stress, we look pale and pasty. Over time, this constant fluctuation becomes damaging to our blood vessels, and they find it harder to react to the change in demand. Through our fight or flight system, you get widespread inflammation over time. The body mounts an immune-like response, ramping up production of white blood cells, causing inflammation and blockages in worst case scenarios. Cortisol is released by the endocrine system. That does let us access energy stores in the longer term and to put out inflammatory fires around the body. But given this heightened state of alertness that it gives us, our muscles are overactive, contracted for long periods of time, sometimes working without oxygen, causing cramp. Nitric oxide is released into our muscles to increase the blood flow to the area, and that acts directly on the trigeminal nerve, in addition to the nerve endings in the blood vessels sending pain signals to the brain because they're widening too much. And all of this brings about the classic stress headache, the ton weight sitting on top of your head, and or the ever tightening elastic band around our skull. So what do? Well, most of the time we pop a pill like paracetamol or ibuprofen. You can have them in a sandwich, that works for me. Both reduce inflammation. Paracetamol is better tolerated by the tummy, and ibuprofen can have adverse effects on breathing in asthmatics. What these drugs do is they will reduce the vasodilation and so stop the pain signals from being sent. That's not a problem in the short term, but in the long term, without addressing the causes of the headache, the vicious cycle persists with more and more heightened physiological responses to the stress. Now, taking paracetamol with caffeine helps because caffeine is a vasoconstrictor in and of itself. That explains why those of you who drink a lot of coffee get headaches if you go without. You're getting rebound vasodilation due to the lack of caffeine's action on your blood vessels, and you get an associated headache. So what do? Well, you have a coffee to stave it off. And that smells a little bit like addiction, but that's over to you to decide. Social medicine for the tension headache involves chocolate, which is packed with a chemical that is turned into a really important mood hormone called serotonin, which has the power to block pain signals. Watching a movie, distraction works. Immersion in something that feels good or funny releases serotonin too. Cuddling up to a loved one helps as well. Hugs are medicine. They release oxytocin, which is also a powerful natural opioid painkiller. It's also known as the bonding hormone. Just make sure that while you're bonding, you watch your posture on that sofa. So just to labor a point I've already touched on, we often attribute the tension or stress headache to our emotional reaction to life around us and how we're dealing with it. But the physical stress causes exactly the same effects, and our brain then interprets that as an emotional stress. So if you have an injury that's causing your musculature to be tense, if your posture is poor, all the same signals are sent to the brain and perceived as stress. So checking your physical stressors as a cause of how stressed you feel is really, really important. Now, of course, as I check the time, we're okay. I can't talk about headache, however fascinating it may be as a phenomenon, without discussing migraine. It's the most famous big bad of them all. It's actually not the worst. Cluster headache is, but I don't have time to talk about that today. Migraine is a specific category of headache, not just because of the suite of symptoms that it presents with, but also the characteristic changes in neural activity that happen across the brain. Whereas all of the previous headaches that we've talked about are vascular in nature, migraine is neurological. The pain still comes from the effect the strange brain activity has on our blood vessels, but that in and of itself is not the root. Because of that, there's a bunch of other symptomology in the migraine attack that we need to talk about. Now, the migraine attack can start days before the pain hits you, but people are habitually bad at recognizing these early symptoms, like feeling a bit down, feeling a bit uncoordinated, finding it harder to focus, yawning a lot, craving sugar, craving chocolate, a bit more needy than usual. Now, a couple of these behaviors are the brain's way of trying to regulate and boost levels of neurotransmitters. They're little chemicals that ensure signals are passed from one nerve cell or neuron to the next. Now, we've met serotonin, which is one such neurotransmitter in the brain. It's important in mood regulation. Dips in serotonin are coincident with migraine attacks. And so we unconsciously try to boost these levels through chocolate, hugs, yawning. Yawning also plays with another neurotransmitter involved in alertness, and that's called dopamine, which is also responsible for that feeling of satiety that you feel after eating something after a long fast, or orgasm, for example. In fact, on that point, migraineurs score 20% higher on the desirability scale, showing that they are indeed trying to self-medicate with intimacy. And we'll never know how many migraines we've headed off or arrested in this or a myriad of other ways behaviorally that we have done. Now, the first noticeable stage of the migraine episode for a lot of people is visual aura. Now, it's really important to note that what's happening in the brain to bring about the sensory experience that happens in all people, it happens in all people who are having a migraine attack. It's just that not everybody is conscious of it. So what's happening in the brain to bring about the aura is happening in all migraine sufferers, but it just may not reach the level of consciousness that somebody actually perceives a visual percept or even a somatosensory percept. It says something about the eloquence of the cortex. It's a lovely phrase. It's not mine. It's Andrea Harriet's from Taipei. But people experience the visual aura as flashing lights that spread over their visual field. Sometimes they're zigzaggy as well. It can also present as a hole in the visual field too. We call that a scotoma. But it can also present as something a bit more somatosensory, so like tingling over the head or half the body, pins and needles, or it could be all of the above. So why is this? Well, the reason is that inside your brain, your neural activity is coordinated into a wave of activity from the back of your brain, where all of your vision is processed, towards the front of your brain. And it passes over areas that govern sensory processing in your skin, your coordination, things like that. So it passes over your visual cortex, passes over your somatosensory cortex, passes over the bits that helps you know where you are in space. So as it does that, it's activating those neurons to do what it is that they do. So you may experience a visual percept or pins and needles or an uncoordinated response to movement. But what's really interesting here is that following this wave of excitation, which is called cortical spreading depolarization, comes a wave of inactivity called cortical spreading depression. Now that happens because all of the activity of the wave of excitation have left all the chemicals that you need for your nerve cells to become active. Things like potassium and sodium, they're all in the wrong place. And so your neurons can't be activated anymore. But you've got all this potassium floating around in the extracellular space and it shouldn't be there. And that actually acts directly on the blood vessels of the cerebrovascular system to cause vasoconstriction and narrowing of those blood vessels. And because of this, the blood flow to the brain is compromised, with less oxygen and nutrients being brought to neurons, and the chemicals that are in the wrong place can't get cleared away. So recognizing this, we get a massive rebound vasodilation. And here comes the pain through the widening of blood vessels and the carrying of that information by the trigeminal nerve, which is even more sensitive than normal, given all those inflammatory chemicals floating around at that time. So we feel it as throbbing somewhere on one side of the head due to the lumping together of the sensation that we saw in brain freeze headache. and sinus headache to a degree as well. But that's not all we feel. So you experience extreme photophobia, noise is louder, the sickness and malaise that is prevalent in a migraine attack, as if life couldn't get any worse with the banging pain that you already have. So what's that about? Well, if we go back to our trigeminal nerve again, where all of the nerve fibers of the trigeminal nerve are bunched together as they are taken to your brain to have the signals that they carry processed in all of those bunching together happens in your brain stem. And that's at the base of your cerebral cortex. And these neurons are going nuts. These activations are passed through the thalamus, which lives just below your cortex, which is the great sorting house for signals and activity in the brain, connects with every part of your brain, and so is involved in all of your functions. That means that you now have uncoordinated activity going to your motor cortex, making you clumsy, perhaps unable to control the musculature, particularly of the face. Erratic stimulation of your parietal cortex makes you really disoriented and very sensitive to touch. And the same thing happens if your temporal cortex is activated, in addition to making it really hard to hold a sensible conversation. And of course, activation of the visual regions makes you very sensitive to light, which is that gold standard of photophobia. The nausea and the vomiting comes from the activation of the hypothalamus, which sits just below the thalamus, and it's connected to the brainstem all by itself as well. And there's a direct connection to an area called the zona incerta underneath the hypothalamus, which is very important in our subjective perception of pain. And that can dial up your perception of the pain, making it seem worse at that particular time. So it's a mess. These symptoms can present in different severities, depending on the level of neurochemical disruption and their status pre-attack. And it's not over yet. Left untreated, the brain's neurochemicals have to reset themselves. And that's helped by the fact that you are, in effect, behaviorally knocked out. Most people who suffer from migraine don't take anything for it, end up in a darkened room. They just can't do anything. And this is why your body has to reset. Dopamine, serotonin, and the body's natural endorphin concentrations reassert control eventually over the vasodilation that's happening in your brain. And it reduces the pain signal activity and the overactivation at the brainstem, and therefore the thalamus, the hypothalamus, and the zona incerta. But afterwards, you are left mentally foggy, very low on energy. And this has been linked to a decrease in blood flow around the brain, which is not surprising given the vasoconstrictor brakes that have had to be put on all of that vasodilation that was happening. Your hormones are all over the place due to the hypothalamic activity, and it takes time to reset that. And it's really important not to ignore this phase. Same as you wouldn't ignore the pain phase, don't ignore the post-drone phase, because that's when everything is getting reset. Well, what gets us to here? And why does this happen to only some people and not everybody? This has been a burning question throughout the ages, but at least we've moved on from the ancient Persian idea that migraine was a symptom of spirits trapped in your head, and the only sensible treatment was to make a hole in your skull to let them out. Now, through correlation, we might think that only people under 5'3" with luxuriant heads of red hair get migraines, and if they have an inverted nipple, they're doubly cursed. They're definitely going to get migraines. But happily, in science, we deal in the currency of causation. So let's talk a little bit about that now. The observation that women are more likely to experience migraines is actually rooted in causation. As you will have noticed by now, I've mentioned hormones with regular frequency throughout this talk. And as you know, until menopause, women's reproductive hormones are released cyclically, whereas men's are more constant. The main culprit here is estrogen, with high estrogen leading to a greater prevalence of migraine with aura, and low estrogen leading to migraine without aura. So whilst the migraine can be triggered by abnormally high or low estrogen levels, estrogen may mediate the threshold at which we are conscious of its perceptual effects, the eloquence of the cortex, if you will. And that's because estrogen is not only vasoactive, but also psychoactive. It directly plays with the activity of our neurons, and the fluctuation that it goes through has the power to trigger a migraine episode. So one treatment would be to artificially set your estrogen levels through the use of the contraceptive pill, where it's set at a higher than normal level, but crucially without the fluctuation. There may be an introductory migraine as you get used to it, but it should help with reoccurrence. What else? Well, there is a genetic link. One form of migraine, which is called hemiplegic migraine, definitely runs in families. And in this type, the inability to control the facial muscles and the unilateral pins and needles is particularly prevalent. But there are 4 other candidate genes, each with a role in the creation of proteins that determine the movement of chemicals into and out of the cells in the brain. And that's, as we know, really, really important in that wave of excitation that we talked about. Now, what turns these genes on and off is a matter for the environment in which we find ourselves. So that again shows that our body does not work in isolation of its place. And speaking of which, one of the most underrated and under-recognized causes of migraine is an overactive visual system. Yep. In the early 2000s, Ed Chronicle from Lancaster showed that people who experience migraine are much faster at simple visual tasks like detecting a line of a slightly different orientation to others, and that this could be linked to a hyperactive visual area of the brain at the very back there. Now, opticians know that your peripheral vision is much more sensitive if you're a migrainer, so you must mention that to your optician if you haven't and you suffer from migraines. I can demonstrate this in my lab by sending magnetic pulses into your brain, but that's probably another story that we just save up for Friday afternoons for kicks. But we are actually surrounded by lines in our world, straight lines that directly activate our primary visual cortex. Things like stripy tops, I realize I'm not helping here, stripy shirts, Venetian blinds. Just surrounding ourselves unwittingly with these stimuli can have the power to trigger a migraine episode, setting up that wave of excitation that is the cortical spreading depolarization that comes from generally our visual cortex. So if you find this particular image here deeply unpleasant, or the lines seem to move for you, then your visual cortex may be overactive. There could be an evolutionary value to this. This hyperactivity may come from our hunter-gatherer past, being able to pick out potential predators or indeed prey from tall grass, with your sight being more acute in dim light. So according to this, the person who experiences migraine is more evolutionarily advanced than everybody else, which is cold comfort when you're in the throes of migraine. Now, vascular changes can cause migraine too, and as we know, our body's chemicals have a part to play in this. So where do these chemicals come from? Well, it's from the food we eat and what it is that we drink. So it stands to reason that these factors have a role to play. Now, we've come across alcohol before, which not only plays with your blood vessels, but also your neurochemistry, affecting your mood and energy levels. This is where the idea, David Nutt's idea of anxiety comes from. Alcohol increases the inhibition in your brain for sure, but then it flips the other way, like the swinging of the pendulum, usually in the middle of the night, and that makes you wake up tetchy, anxious, negative. The other ones that the other triggers that people blame are chocolate, Chinese food, cheese, they're the most prevalent. Well, for most people, we can let chocolate off the hook. The coincidence of eating chocolate prior to a migraine is because of the behavioral drive to self-medicate and regulate serotonin concentration. We talked about this already. However, one unifying factor behind the others is tyramine. And this is found in processed foods, ripened cheeses, miso, soy sauce, cured meats, fish. It does lead to vasodilation, and it can indirectly lead to the brain activity seen in migraine. However, you might also remember me talking about nitrous oxide and how it is an agent of vasodilation seen in tension headaches and stiff muscles. Well, nitrates are found in leafy green vegetables, but are also found in great quantities in meat as a preservative. They're powerfully antibacterial. So any salted, cured, or smoked meat will have artificial levels of nitrates, and usually quite high levels too. Now, what's interesting about migraineurs is that they've been found to have an abnormally high concentration of bacteria in their mouths that are specific for breaking these nitrates down into nitrites, which may introduce more nitric oxide in the system, and that causes vasodilation. It's actually how the glycerol trinitrite spray, or the GTN spray, that people take for angina works, because how that's delivered is by a couple of sprays under the tongue. It means that the bacteria in your mouth breaks those nitrates down into nitrite that causes vasodilation, that helps when you're in an angina attack, because you want vasodilation around the blood vessels of the heart to widen the blood vessels to get around any blockages that may be happening or may be present. But it can actually cause migraines in those patients as well. So what's the value of migraineurs having more of these bacteria? Well, it may be that this is just another way in which people can control their vascular system, particularly that around the heart. But if you've noticed that you get migraine on days that you started off with a bacon sandwich, then why not swig your mouth out with some mouthwash to decrease those nitrate busting bacteria to more manageable levels? Sometimes it's a really simple fix for a big problem. Now, many say that monosodium glutamate, which is found in lots and lots of things, from breast milk to crisps, is a given trigger for migraine. But actually, this is one of the urban myths that we must debunk. There was a big cultural misappropriation against Chinese food, and this was due to a letter to the New England Journal of Medicine that queried its involvement in a feeling of malaise having eaten in a Chinese restaurant. MSG is commonly used in Chinese cuisine, and it is in fact down as a trigger in the International Classification of Headache Disorders. But the evidence of both its prevalence and mechanism of action is ropey at best. It turns out that if you eat 6 times the normal amount of MSG on an empty stomach, you can induce facial pressure, chest pain, and headache. However, the interesting thing is that the original letter to the New England Journal of Medicine that triggered these studies never mentioned headache or migraine, but rather numbness, general weakness, and palpitation. And finally, wine. Aside from the alcohol issue that we've met before, lots of people in the UK swear that red wine causes headache. However, people from France and Italy think that white wine and champagne or Prosecco are triggers of headache. Now, I'm a scientist of good standing, and from many years of personal experimentation in this issue, I'm with the French and Italians on this one. It turns out that white wine contains more sulfites than red wine, and these are linked to histamine release. And we came across that in our sinus headache chat. Sulfites might boost serotonin, but whilst that will improve our mood, it may lead to vasoconstriction, which will eventually lead to rebound vasodilation. And that's the stuff that headaches are made of. But sulfites are actually found in much higher concentrations in crisps, raisins, dried fruit, and not that many people complain about those. Now, flavonoids are 23 times more prevalent in your red wine than your white wine. Flavonoids stop phenols from being broken down. And phenols can have a big immune inflammatory effect in the body. So left unchecked, phenols will cause this inflammatory effect. It may be that migraineurs have a lower concentration of phenol busters to begin with, and so alcohol for them has a double whammy effect. Interestingly, only 10% of migraineurs report alcohol as a specific trigger for their migraine, which again is a bit of an urban myth and bash up against what it is that we always think are those triggers. So what do we do? Well, we know that prevention is better than cure, but in women with hormonal fluctuations, this can be very difficult to control. We can take drugs to combat the pain aspect, of course, and we can use prescription drugs like triptans that directly change the concentration of neurotransmitters, and they can be used as the migraine attack begins. Newer drugs that alter the concentration of other proteins like calcitonin gene-related protein that is prevalent in higher concentrations in migraineurs can be used as a preventative measure. They've just come on the market and have been through the regulatory process by NICE. So we've spent the last 40 minutes describing different types of headaches and how they come about and how they feel the way they do and what we can do about it. But phenomenologically, having a headache can be a pretty lonely place to be. Only you are experiencing this pain inside of your head, and it's really easy for others to dismiss it and tell you to get on with it. But you have the power, ultimately, to work out what it is about your life that's triggering them, knowing now, as you do, that you should look outside of your head, outside of your body even, and how you use your head and your body to bring about behaviors in the environment in which we live. I've barely scratched the surface here in talking about all the influences of our lives that lead to headache or lack thereof. And that's testament to the depth of how fascinating an experience it is, really, to be human. And that said, thanks for being here. And I'll take your questions about all the things I haven't talked about yet now.
Thank you very much, Amanda. I'd like to thank everybody for coming today. I think it's been a really great talk, and thank you, Amanda, for this amazing presentation. This event has been recorded and it will be available online in the next few days on the Wolfson Research Institute for Health and Wellbeing's website under past events. So again, I'd like to thank Amanda, and I'd like to thank everybody for coming, and we'll see you all again very soon.
Thanks so much.